Welcome to Tuesday, April the 7th. And today we're going to do the Robinson annulation. And this is the last reaction that will be on your Quizam 4. That's tomorrow. So hopefully you're becoming very familiar with making your enolate as your nucleophile, and then that enolate attacking some form of electrophile. And so hopefully you feel comfortable with an aldol reaction where your enolate is either going to be a ketone or an aldehyde, and your electrophile then becomes the carbonyl of a ketone, aldehyde, or possibly an ester. And then with the Claisian condensation, your starting material, your nucleophile will be your an ester, and your base would be whatever that alkoxide is for the ester, and then your electrophile then would be the carbonyl of an ester. And if you have an ester as your electrophile, then you're going to make a beta keto carbonyl. Okay, because when you have the collapse of the carbonyl, the ester is your leaving group, and that's how you get the keto. With an aldol, when you have the collapse of the carbonyl, well, actually, you don't have the collapse of the carbonyl because the tetrahedral intermediate gets protonated, and then when you lose water, you get an alpha beta unsaturated ketone, or we'll say carbonyl. Okay, so those are the big ones. We also talked about Michael reactions, and that's a 1,4 system. So something like this, where you have 1, 2, 3, 4, and that fourth carbon is a delta positive, so it's an electrophilic, and your nucleophiles then will be soft nucleophiles. We talked about soft nucleophiles. These can be negative carbons. A nucleophilic carbon would be a soft nucleophile. And then if you put R groups with copper, lithium, the cuprate reagents, that is your nucleophile. And so we have the Michael. We also have talked about using enolates, or not enolates, enamines. We talked about enamines, and particularly secondary amines like pyrrolidine, and how they can protect some form of aldehyde. Let's make this an aldehyde. So you would get something like this, and then your nucleophile then would be this carbon here, right? We talked about that. So that would be a nucleophile. And so if you treated that with a primary alkyl halide, and then you treated that with acid and water, you would get back your carbonyl, and that is a form of alpha alkylation. So that would be your product there. We talked about alpha alkylation. So that means your enolate will attack a primary alkyl halide, or it can go after halogens. We also talked about the different types of intramolecular reactions, and these usually they form rings, and those rings are 5 or 6-membered rings. We've also talked about retrosynthesis. Okay, so you need to practice these. Yesterday we talked about the haloform reaction, and this makes carboxylic acids from methyl ketones and halogens. We talked about the acetoacetic acid and malonic ester synthesis, and that was in your POGL. So if you have something like, this is your acetoacetic acid, and you react that with base and like a primary halide, then you get alkylation on the alpha carbon as such, and acetoacid, sorry here, this would actually be an ester. So let's write this acetoacetic ester, and then your base should be something like this, because you would want this R group to match your ester here. Okay, and so then your product would be something like this. Now, when you treat this with acid and heat, the first thing that happens is you hydrolyze this ester. You hydrolyze that ester to the acid, and then the heat, you decarboxylate. So you're going to lose CO2 in that mechanism here. You have to turn that ester, the acid, upside down. So you see here, I've kind of inverted it. This is a 1, 2, 3 carbon system. So this is alpha beta. So this is beta keto esters, can be hydrolyzed in acid and then decarboxylated. So you can look for that. What happens here, the mechanism, this oxygen takes this hydrogen, those electrons collapse here and they go here. You get your enol, right? And then we've also talked about how enols tautomerize, and I do it this way, so to save time. And so there you have a substituted ketone. So if you look at this, this is 1, 2, 3, 1, 2, 3, and then the R group, 1, 2, added here, and this makes ketones. If this was the malonic ester, and you did this, malonic ester looks like this, put ethyl esters on there, okay? And so if we add sodium ethoxide, and then we also add alkyl bromide, then you get this here, okay? And then under acid and heat, we're going to, once again, decarboxylate. So first, it gets hydrolyzed, and both of them are going to get hydrolyzed here, okay? So you get OH, OH. So that's the first thing that happens is hydrolysis, and then we're going to lose CO2 from one of these. Once again, you have a 1, 2, 3 system. We're going to lose this one. Doesn't matter which one we lose. Okay, so I'm going to invert this one here when I draw that mechanism. So I invert that like this, and then you have these electrons take this, they go here, and you have an enol, 1, 2, 3, 2, 3, and then that tautomerizes. And so what does that look like? That goes back to the carboxylic acid. So here's the 1, 2. There's 1, 2. There it is, 1, 2. And then you're adding these carbons here, 1, 2, 1, 2. And this makes a carboxylic acid. Okay, so that's a little bit of a review, and that was in POGL 23C. So those are the reactions so far that you will be tested on tomorrow. Now, what I want to look at here today in our last reaction is the Robinson annulation. Okay, and this is a ring forming reaction. So you might want to get a new reaction sheet. This uses a Michael reaction, and that Michael acceptor, in particular it's a Michael acceptor, is called the MVK. This is methyl vinyl ketone. So what does that look like? It looks like this. So this is a methyl, there's your methyl, vinyl, there's your vinyl, and ketone, there's your ketone. Okay, so you use a methyl vinyl ketone, and then you have some form of ketone. So plus MVK in base, so sodium hydroxide, you're going to get a Robinson annulation. So you use some form of ketone, you use the MVK, those are your substrates, this is your reagent, base, and you're going to get a Robinson annulation. So it's going to be ring forming. So let's look at that reaction. CH3, and we're going to react this with methyl vinyl ketone, MVK, and we're going to throw in some base. Now the first thing that's going to happen is you're going to form the enolate with your ketone. Okay, remember this is a Michael acceptor. The MVK is a Michael acceptor. Okay, so that means when you have this 1, 2, 3, 4 system, this is a delta positive here at the 4. So this is going to be your electrophile. So the first thing we're going to do is we're going to do our enolate. And so we go ahead and take this hydrogen here, and you form your enolate. I'm going to do my little monkey face. Okay. And then this is going to be attack the MVK. So we'll add that on. Okay, we're going to do 1. This goes here. That's 4, 3. That's 4. This is 3. This is 2. Okay, and looks like that. And between the 3 and the 2, you get the double bond here. And then, of course, that gets protonated to form an enolate. 4, 3, 2, 1, OH. And then we tautomerize. And so when you add this together in base, this is the first thing that happens. You form your enolate, and I need more space here. All right. Four, 3, 1, 2, 3, 4. 1, 2, 3, 4. Okay, so this is what we formed so far. And now you still have base, and it's going to form a ring. And this is going to be now your electrophile. Okay, so this ketone that was your nucleophile is now your electrophile, and we're going to form a six-membered ring. So 1, 2, 3, 4, 5, 6. So I do the 1, 2, 3, 4, 5, 6. And I go ahead and just draw my electrophile like that. This is going to make that, it's going to deprotonate to make your enolate there. And then this is going to come here, attack that electrophile. And this is an aldol condensation. Okay, so I go ahead and keep the CH3 here. This is going to come up and make the O minus. And then we have, that's 5. This is 6. So we're going to do another six-membered ring. 5, 4, 3, 2, 1. And on the 2, you have your ketone. Okay, so this was your alpha carbon. There's your alpha there. This has become your beta. This is your beta. And then, of course, in the aldol that gets protonated, OH, there's your alpha, there's your beta, okay? And then with heat, you're going to lose water. This is an E1CB mechanism. So you're going to lose that hydrogen, you're going to lose water, and you're going to make an alpha-beta unsaturated product. There's your alpha, there's your beta. So there's your double bond. Okay? And that is the Robinson annulation. So let's review. Okay? It's going to make a ring. It's ring forming. You use the methyl vinyl ketone most often. So your first step, this is a Michael acceptor plus a ketone. Okay, ketone is going to be your enolate. This is going to be your nucleophile. You can say that's the Michael donor. And it's going to attack your Michael acceptor. You're going to use sodium hydroxide base. First thing you're going to do is you're going to do a Michael addition. So your enolate will add to carbon number 4, delta positive of the methyl vinyl ketone. Then you're going to be getting a diketone product. Okay, so that's step 1. Step 2, you had a diketone and you generated an enolate to form a six-membered ring. And this was an aldol. So you finish up with an aldol condensation, and it formed an alpha-beta unsaturated carbonyl product that was fused ring. Okay, so you made a fused ring. So that's the summary. Now, let me give you a reaction. I tell you what I'll do is I will work another one. I will give this to you, and then you have to figure out the starting materials. Okay, so here you go. This is a Robinson annulation. reaction. Okay, so we're going to do a retrosynthesis. So what I want you to do is I want you to label your alpha, beta, and put a line through it. Okay, and so then we're going to do that. We're going to break it down. Okay, so the beta ketone. You see that? We keep the ring here. A lot of people miss this a lot of times. So I kind of even draw it the same way, right? 1, 2, 3, 1, 2, 3, 4. And we have a carbonyl, and then we have a CH3. Okay? So this is our diketone. Now, how did we form the diketone? Okay, it came from a methyl vinyl ketone. So let's draw the methyl vinyl ketone. This is your methyl vinyl ketone. Okay, so let's see where those pieces are. Well, I guess it's not exactly a methyl vinyl ketone. It doesn't have to be. Okay, so let's look at this. This is your alpha. Okay, and this is your new bond, and this is your beta. So those are your bonds. And so this is 1, 2, 3, 4. 1, 2, 3, 4. And so if we break the other one, these are your starting materials. Okay, that's your alpha. All right, and you put this in base. So what I would like for you to do is two things. I would like for you to show me, this is for your online POGL, show me the mechanism to make the product shown here. So I've given you the first step in base. You show that mechanism that gets you this product here, and then show me the mechanism to go from your diketone to your Robinson annulation reaction. And then the second thing is I want you to break this one down. And I want you to show me the starting materials for this one. And then you can also work it forward. And I want you to break this one down. I want you to do a retro synthesis for this Robinson product. And I want to see those starting materials.